one method today, the separable. Next time, like I said, we're going to focus on Euler's method. That is a numerical method that we do. Euler is a mathematician. The letter E is named after Euler. Yeah, Euler's one of the big ones. Please don't say Euler. This is not right. Euler's method, and then after that will be solving using a linear method. Today we're going to do separable. Separable is the easiest. You would always want to use separable if you could, but not all the equations are able to be separated. So we'll start here. We could say y prime. For these, to say y prime, we need to always change it back into dy dx. Please again keep in mind, y is a function of x. That's important to remember. In this case, my goal is to get everything x to one side and everything y to the other side, including the infinitesimal. Okay? So in this case, I'm going to get all the x's to the right-hand side and all the y's to the left-hand side. It's going to kind of look like I'm cross-multiplying. Technically, that's not what I'm doing, but we get the idea. After that, I'm going to actually integrate both sides. Notice it's dy, so we're okay with the y. We've already had the discussion about just putting all the c's on one side, right? This answer would be, okay, now what you want to do is you want to try to solve for y if you can. In this case, we can. I deliberately skipped the algebraic steps. I want you to talk about it and figure out what happened. How did I get from the second to last step to the very last step as a solution?
So did he cancel out the 1/3 and then he did the cube root of both sides? No. I'm not completely retarded.
My friend says nobody is. They just make themselves that way.
I'm gonna immediately disagree with that.
He's a narcissistic person, so.
So he would absolutely believe that.
So, listen up please. I would not be able to solve for y if it was squared here. The reason is because I'd end up with the plus or minus mess. Once we do that, then we can't do it. If we can easily solve for y, then we try to do that.
Do
Like I did
substitution.
with, I erased it, the population growth, where we could actually solve for p of t. Now, notice if I multiply through by 3, I actually end up with 3 times c. Okay, I just absorbed that in and just called it c again. Even if technically it's not correct. I think your textbook changes it from 3c to k or something like that, but we're going to abuse that plus c so badly that it's fine. Alright, let's say I want to know what that value of c is. As of the way that it is, there's nothing I can do about it. Sometimes what's given is what's called an initial condition. I wanted to use their numbers, yeah. Let's talk about what an initial condition is. Pull out your graphing calculators, please.
There, you can just do one.
So here's what we're going to do. You are going to graph 5 graphs. Y sub 1, Y sub 2, Y sub 3, Y sub 4, and so on. What you're going to graph is this here, where C equals -2, -1, 0, 1, and 2. So Y sub 1 is going to be the cubed root of x to the 3rd power minus 2. Graph. You're going to plug all those in, and we're going to see what we get here. It'll take a few minutes. I think it would be easier to plug it in like this, myself. I think it's easier if you do this. And the whole thing raised to the 1/3 power. Make sure you set your window up so that it goes from -3 to +3 in both the x and y direction. Yeah, so set your window to go from -3 to 3 in both the x and y direction. Please. Super K fortune cookie. Who brought that? Oh. Came with the pie? Who brought the pie again?
Still going.
Thank you. I won't call you Gimpin. No, that's very nice.
It's like artwork.
What's it say?
Any impatience you show will only create more stress.
With your pants down.
So hurry up!
So accurate.
Okay. Yeah. -3 to 3. On both. Both. What you're looking at is called a family of solutions. Family of curves. These are all potential answers to this differential equation. And you can see I randomly pick values. There's actually an infinite number of possible solution, curves. Notice one of them is the diagonal. Why is it the diagonal? What do you think that is? Which one? Which of these do you think that is? 0. Yeah, when c equals 0, I get y equals x. Which is just a line, right? Alright. What we want to do with the initial condition is, what's given is, whatever this was set up for, maybe it's a velocity or something with position in there, I don't know.
Graph.
But whatever this was set up for, whatever y represents, we're saying that we know a little something about what's happening right at the beginning. So for example, let's say that I want to apply a heat source to a piece of metal. So I take some sort of piece of metal and I apply a heat source. my initial condition would be knowing what the temperature was right before I put the heat source on there. Does that make sense? And those types of things are often very easy to know. What is the initial condition as we do that? So in this case, we're saying initially at time index 0 or whatever, y is equal to 2. The temperature is equal to 2, whatever. So now that we know this, we should be able to pin down which differential equation we're interested in. So we're going to do this. Note that x is 0 and y is 2. So here we go. We're trying to figure out what c is. How do I solve for c now? Cube both sides.
Cube root?
What did I, dang it, cube root, yeah. Thank you, cube root. How are we doing? Start out, separate the variables. Get all your x's on one side, y's on the other. Integrate, solve it the best you can, if it can be solved. In this case, it can be solved. I showed you some potential solutions. We went through with the initial value that we were given. At x equals 0, y is going to be 2. We plugged that in to figure out what c was going to be. Now we have a specific solution, opposed to a general solution to the system of equations. Okay? All right. I would like to give you a differential equation with an initial value, and I'm going to ask you please to come up with a solution.